Power wheelchairs often suffer damage during airline travel, and the damage can completely remove someone's independence. As someone whose grandmother immigrated from Spain to America and suffers polio, I've witnessed this problem firsthand. On a flight to the US, her wheelchair was seriously damaged, causing her to need a new one. Without a new wheelchair, my grandmother would have lost her freedom of movement. So we were eager to start on this project, tackling these problems to prevent any more wheelchairs from being damaged. When we started our project, our question was simple. How do you protect a 350-pound wheelchair and cargo, while also keeping the solution practical for airline workers?
Our initial concept was a rigid box, simple, strong, protective. But the more we studied the problem, the more we realized a fixed, bulky structure would create a new issue. Airports don't have the space to store large equipment. We were inspired by a senior capstone project working on a similar problem. The senior capstone team made their box stackable. Inspired by this, our challenge became, can we design a protection pod that not only secures the wheelchair, but takes as little space as possible when not in use? That became the central engineering problem our team set out to solve. That pushed us to rethink the problem using constraints. The pod must survive cargo handling, it must secure the wheelchair from shifting, and airline staff must be able to store multiple pods efficiently. From our early sketches and the ideation chapter of our report, we decided to make the pod foldable for minimum space occupancy. We engineered the pod as a continuous hinged loop. The whole structure could expand and collapse predictably. We referenced heuristic cards like lower and fold during ideation, and this guided the motion logic we eventually used. However, how could we make the design sturdy enough to hold a 350-pound wheelchair? That's when we discovered a key insight. We would make extendable supporting beams that would lock in place and hold the box open.
Another thing that we didn't realize until we took a more detailed look at the capstone steam project was that using sheets of metal for all 6 sides of the box was going to increase the weight significantly without adding more structural support. Because we wanted the box to be collapsible, that meant that the sides also needed to be collapsible. By using 6 telescoping arms, 3 on each side, we could effectively protect the wheelchair from impacts on its side. And by utilizing this mechanism, we managed to save weight without affecting the compactability of our airpod. This way, airlines will be happier because they have to carry less loads, and airports will appreciate the little space our airpod takes when not in use.
At the same time, we realized how important securement was. A pod that only surrounds the wheelchair isn't enough. Not when wheelchairs face tilting, vibration, and sudden movement during loading. So early in the design, we committed to integrating a seatbelt subsystem. This wasn't an accessory, it was a load-bearing part of the design that had to integrate tightly with Tilo's frame and Mario's arms. We were inspired by the senior team's testing, seeing that they used a ramp at a 30-degree incline to ensure the wheelchair did not move from the base.
Through this project, we learned how to adapt our design to different challenges. Although our idea in the very beginning fundamentally resembles our design today, there are many parts that we changed, such as the straps of the seatbelts and making the back panel hollow to allow space for the arms and the hooks.
Our advice for future teams is simple. Learn from the designs that come before you. Talking with our capstone mentor during the cornerstone to capstone meetings was very useful in making us think about how we could improve our design, reminding us to communicate with each other and stay on track. In the end, this project taught us to stay adaptable, communicate clearly, and build on past ideas to create a stronger, more refined design.